Okay, are we all there? Assalamu alaikum wa rahmatullah. To begin with, today we are looking at question 5, as I said, November 2019. Write it in your books. Let's look at a question. It says, an object of mass 1.8 kilograms slides down a rough curved track and passes point A, which is 1.5 meters above the ground, at a speed of 0.95 meters per second. Right, so you're lucky the diagram was drawn and it gave you the details. Draw a sketch if you want, or if you don't want, it's fine because it's quite well done here. You got this object, the mass is 1.8 kilograms, the initial velocity is 0.95, and then it's going down a rough surface. The rough means, the rough tells you it's going to be friction, right? There's going to be a frictional force, so that you know already, right? And then it slides down the slope, and the velocity at the end of the slope is the velocity is 4 meters per second, and it is 1.5 meters above the ground. So when it's 1.5 meters, what do we know? It's above the ground. If it's above the ground, that means what type of energy does it have? It has potential energy, right? So now define the term conservative force. All right, so you're are you writing? Let's write down the answers. Conservative force is what? Conservative force. A conservative force is a force for which the work done is independent of the path taken. That's the definition that we learned, right? A conservative force is a force for which the work done is independent of the path that is taken. Okay, and if you continue, the next question, it says, name the conservative force acting on the object. So what's the conservative force acting on an object in this case? The conservative force will be the gravitational force acting on this object. The non-conservative force acting on an object will be the non-conservative force now, right? The conservative force will be gravity. The non-conservative force will be friction. 5.3 is mechanical energy conserved as the object slides from A to point B. Choose from yes or no and give a reason for your answer. The answer will be no. Why will the answer be no? Because of friction, right? Energy is transferred to other forms of energy in this case. Okay, so the answer will be no. There is a frictional force acting on the system. That will be the answer that we use. I'm just looking at the memo. No, there is a non-conservative or frictional force. It is not an isolated system. You could have said that also. The net work done by the non-conservative force is not zero. That's another answer. But to put it simply, you can just say there is a frictional force acting on the system, right? Then if you look at the next question, it says calculate the potential energy acting on the object at its maximum height. Let's see, calculate the gravitational potential energy of object when it was at point A. So the gravitational potential energy at point A, to work that out, what will we do? Work out potential energy. What's the equation for potential energy? EP is equals to mgh. Right, so we know that EP is equals to mgh. What's the mass that we are looking at here in this case? The mass is 1.8 kilograms. Gravity G will be 9.8. Potential energy is not a vector, so we don't have to worry about plus and minus. And then H will be the height, which is that it is above the ground, and that will be 1.5, the height. So take your calculator, work out 1.8 times 9.8 times 1.5. Can somebody give me the answer? I'm waiting for an answer.
26.46.
26.46. And then what's the unit? Don't forget.
Joules.
Joules, right? 26.46 capital J. That's very important. Don't forget that you don't lose marks unnecessarily. unnecessarily there, right? So that's important. Now, the next question, quite interestingly, is use energy principles. Calculate the work done by friction on an object as it slides from A to point B. Now, I'm going to give you a few minutes.
Mani,
Yes, yes.
can you please redo 5.3?
Sorry, Maaf.
5.3.
5.3. Is mechanical energy conserved as the object slides from A to B? Choose from yes or no. The answer will be no. Give a reason for your answer, because there will be friction that is acting on the system.
Okay, Jazakallah.
All right, I hope you
Hey,
got it.
man.
5.4.
What is the answer for 5.2?
Name the conservative force acting on the object. What did it cut, guys? Did I miss something? The conservative force acting on the object will be gravitational force. Gravitational force.
Okay, Jazakallah.
All right. Okay. Can we go on to 5.5? Are you all with me? Talk to me, somebody. Are you all right? I don't know if you're okay or not. Somebody say something. Hello.
Yeah, we can move on. I'm
5.5.
fine. I don't know about anyone.
Right. Let's go to 5.5. Use energy principles to calculate the work done by friction on the object as it moves from point A to point B. So energy principles, what are the equations relating to energy principles that we the energy principles? Write down your what information we got. Write down information there. V initial is what? 0.95 meters per second. Right. I think we need to write. I didn't write down. Should I write? I'll just show you all the memo. I don't like to just show you all the memo because you won't know what's happening. Some of you will, but you know, let me see if I can start writing. Start, you guys there. Use energy principles to work out the work, calculate the work done by friction on the object as it moves from A to B. So write down your information. What's your final velocity? Right, so V initial will be, I'm starting to write. Let me just copy this for you. I'm just copying, right? Keep on, start writing, you guys. Work out what you can. How are you going to work out energy?
Mani, can you show the question again? I
What
want to
is
see
that?
this. No, I just want to see the top of the question.
Is that better?
Gee.
Sharp.
Okay, Jazakallah. You can go back to
The question.
what? Gee.
No, sharp, nah? I can make it smaller. Wait there, we can do all one day. How's that? Can you see everything?
Gee.
Right. So try and do it. I'm just getting it on Word here so that we can maybe write something on Word. Use energy principles. Right. Salam alaikum. I'm just putting it here for you guys. Right. So while you are busy, I just want to ask you, what are you going to use? You're going to use, AK, you had a question. You're going to use WNC is equals to delta EP plus delta EK, or you're going to use work net is equals to delta EK. Which one is easier for you?
W net
Won't
is equal to
work
delta
net.
EQ.
Sorry, one of you at a time.
Chama.
AK.
Talk. I didn't hear what you'll say.
Okay, I'll use W net is equals to delta K.
Delta EK. All right, go for it. All right, so what's your W net? What's your network acting on the system? What's your network acting on the system?
Your work of friction and your
It's
work of
okay,
FG
work.
parallel.
Good. All
Yeah.
right. So you go for it. Let's see how it goes. And if somebody else, anyone using WNC? Hey, this thing is such.
Yeah,
Yeah, talk to me.
I'll use WNC.
Okay, so WNC is equals to delta EK plus delta EP, na? And then, do you have all the information to use that equation? Talk to me.
I think so.
Right, write it down, put it step by step, and we're going to check it. I'm writing it also down myself here. I don't know, my computer is another story, but we're getting somewhere. Okay, so try something. I'll show you what I've got just now. Ah, yes. Okay, we're getting somewhere. Can you all see the screen or no? Right. I think there's a screen. Okay, I've got the one. Sorry. Let me get the other one. It's not copying. I'll be with you guys now. In the meantime, I hope you're continuing with the sum.
So Moin, what was the answer for 5.5?
Wait now, wait for me.
Okay, Mark.
What you got?
Minus 12.87.
I got the same.
87 joules.
Okay.
Gee.
Yeah, it's correct. But now I'm just trying to see which way I'm going to show it to you. This whole thing is such a mess here. Wait. I have to blame myself. Ne? Okay. Right. How many of you all did it using WNC?
I did.
Who used WNC?
I did.
Right. Anybody else?
Me.
Two. Right.
also
Anyone
used
else? Was it another one? Three.
She.
Okay. Right. So if you use WNC, what will we say? WNC is equals to delta EK. Let me show you all the memo now. Wait. Right. So that we cover everything. 1 minute there. You know, we're just learning all these things. 1 minute, new share. 1 minute. Okay, so if you're using WNC, is this what we have? We use delta EK plus, they got delta U, but we'll use delta EP. We'll say delta EK plus delta EP. That's what we've been using, isn't it? So your delta EK will be a half, it's half. Mass is what? 1,8 Vf squared, which will be the final velocity, which is 4 squared, minus a half, again, we'll say mass 1,8, V initial will be 0,95 squared, whichever way you want to do it, right? Plus your mass will be 1,8, gravity is 9,8, and your final height is 0 because it's on the ground. We'll take that point as the lowest point, and your initial height was 26,46. Where did they get that from? 26,46. Or we don't have to work it out. We worked it out in the sum before, isn't it? We worked out the potential energy in the sum before 26,46. So potential energy final is 0 and potential energy initial will be 26,46 joules. And you subtract that, you got 12,87 joules. And then WNC will be friction. So that will be the friction. That means the energy that is taken out of the system gets changed into other forms of energy. Any questions if you did it that way? You okay? Now, what I want you to do, if you did it this way, do it the other way. All right, try the other way as well. We'll use W net is equals to delta EK just for you to get an understanding. And those who use W net, do you understand this way of doing it using WNC? You write this also down. So write down both examples so that you know exactly how to do it both ways, and then you can be comfortable and decide which way you want to work. All right. So I'm going to explain the other way now. If you use work net is equals to delta EK, then what's your net work? Your net work will be your work done by friction. It's your work done by friction, and your work done by the gravitational force is equals to half mvf squared minus half mvi squared, right? So what's your work done by friction? That's what we want to work out, right? And plus your gravitational force will be 26,46 because we worked that out in the sum before. Is equals to a half is half, final velocity is 4 squared, and your initial velocity is 0,95 squared. So if you work it out using this way, then we can work out your work done by friction will be 12,87 joules. Okay, so I think it's very important for you to look at this carefully and see that we have two ways of doing the sum. And you must, I think, to be safe, learn both methods and then choose a method that you find comfortable and use that method. Then when you're going through your work at the end and when you're going to check your work, try the other method. All right. Sometimes you can't do it both ways. It depends what's given in the information. I chose this sum specifically to show you two ways of doing the sum. Okay. So I hope you got that. Any questions on this?
Mulim, why is WGMGH?
Because your work done against gravity, you see, the object is on a height, all right? So I'll just show you the picture again. Let me just share the screen. Oops,
Maybe isn't it because your delta x cancels out?
what do you mean delta x? I'm not following.
When you say W, your work of your force of gravity is going to be your WFG parallel. So your WFG parallel is made of mg sine theta, and sine theta is Wy over Wx. Not that, what am I saying? Delta y over delta x.
Yeah, it's delta y over there.
Yeah, and then you have delta x in your force in your work equation already. So your delta x and delta x cancel out, and then you just left with your Wy, which is your height.
I see what you're saying, but just to put it simply, AK, you just have to take it as it's your gravitational force. If you look here, the object is on a height. Somebody's screen is on. Okay, let's see what you did. You're showing us. Can everybody see that screen? MGH, right? Go a little out. Can I share your screen? Is it possible to share your screen big? I don't know.
I don't know.
I also don't know.
William, I think you need to stop sharing and then he'll be
Okay,
allowed
let's
to share.
stop. New share. Can I do new share? No? No. Now how can I do it? I stop sharing.
Sure. Oh, fuck.
See what AK did there, but he's making it very hard. All you have to know is you were at a height and you came down. So you lost in terms of gravity. You understand? Make co-host. I can do this. I'm making you a co-host. Share your screen.
Maybe this is my screen.
Right. No. Now you share your screen large for everyone to see.
Oh, because it's
So now at the bottom there, you go to you are screen sharing. Go to new share. You know, new share at the bottom on the top, and then you share your screen. Oh, but you're using your phone. Né?
I'm using my camera, man.
Yeah, now you're going sideways. Let's see. Send it on the WhatsApp. We'll check it.
Okay, man.
All right, but basically, you see, I'm just saying that you don't even have to. You can just say basically, you see, the object was at a height of 1,8 meters above the ground there, right? So now the object was here. So now the object is on the ground. So because the object came to the ground, it lost the potential energy. So that's why it's MGH. Does that make sense? Hello? It loses
G.
potential energy.
G.
Is it fine? No?
G. Jazakallah.
Okay. Okay, I see the photo came on the WhatsApp. You just have a look if it makes sense for you. Whichever way works for you, as long as you understand the system, right? I'm going to send this memo also to you on the WhatsApp, and you can have a look. Let's just finish the sum. What is the value of the net work done on the object as it slides from B to C? What do you know? What do we know about BC? We know that BC is, it's the rough, what's it? It's rough at point A. The object reaches B at the bottom of the track and moves to C. They say BC is frictionless. All right. So it's frictionless. There's no friction. There's no other frictional action acting on the system. So what is the net work done on BC? Is there any forces acting on it? It will just be moving, right? So that's why the net work that's acting on it will be 0. 5.6, the answer is 0. Sure. Let me see that memo. I want to show you all the memo. You can just check if I missed something. Let me share. New share. 1 minute. Make it small now. Okay, maybe that's too small. You want to see the earlier sums? You all got it all done? If you look at number 5.5, there's another way of doing the sum as well. If you can say E, potential energy at A is equal to potential energy at B less the frictional force. There's another way of doing it. You all okay here? Any questions? Talk to me. Can we do a next sum? I
Sure,
already.
fine.
Right, sharp. I'm taking this off, right? I'm sending this to you. Okay, let me try to start a new share now. Let's see if I got it here behind. Oh yeah, yes, it's short. Okay, you'll start working with the sum. In the meantime, I will send you some stuff on the WhatsApp. The WhatsApp is working. Okay, yes. You can see the sum? Sorry, I don't even know. All right, start.